In today's lesson, we are going to learn about the rusting of iron. Earlier lessons, we looked at how iron is extracted from the iron ore. And then later on, we looked at how iron is converted to steel. And we also looked at some of the uses of iron and steel. And today's lesson, we will learn how what rusting is, what are the conditions that cause rusting, and how rusting can be prevented. Okay, and we will also, after the rusting part, we will also look at the extraction of zinc. Now, what is corrosion? Who can tell me what corrosion is? Yes, good. Metals metals react with oxygen and water vapor and other chemicals in the air, and then you can see that the surface becomes damaged. So this is called corrosion. Now, chemicals in the air attack metals and the surface gets eaten away. So you call this as corrosion. Now, rusting is also a type of corrosion, but rusting is specific to iron and steel. Okay, because rust is a chemical compound. So it is not proper to say that copper rusted or magnesium rusted. Iron is the one that will rust. The other metals, you can use the word they corrode. Now, what is the color of rust? Yes, correct. It's a red-brown powder. Now, rust is mainly hydrated iron 3 oxide. So let us see how rust is formed. Rust is an oxidation reaction. Now, oxidation is the gain of oxygen or the loss of electrons. So you can see here that iron reacts with oxygen and water to form hydrated iron 3 oxide. And this part that you see here, now this is not an addition or subtraction, it's a dot. Okay, it's a dot. So it means that the water molecules are coming together with the iron oxide molecule. So this is hydrated iron 3 oxide. Now, from this equation, you can see that both water and oxygen are needed for rusting to take place. Salt dissolved in water, that is salt water, it doesn't actually cause rusting, but when the object is already rusted up, it will make it even faster. The rusting process will be even faster. And the same thing with acid rain. So these things speed up rusting. Okay, so what you need to know here is that rust is a chemical reaction, and rust is hydrated iron 3 oxide. Okay, now is rust a slow process or a fast process? Slow process. Is it a useful chemical reaction or harmful one? Yes, it's not a useful chemical reaction. Why? Yeah, because rust makes the metal brittle, and it has to be replaced from time to time when it is used to make buildings and other things. Okay. Now, let us look at the conditions. Now, I will show you a video and you observe what are the conditions needed for iron to rust. All right. So now let me ask you a few questions from the video. What were the conditions that were changed? Okay, so there was water, then there was salt water, and then there was boiled water, and then there was no water but only calcium chloride, and there was one test tube with no water but with calcium chloride. So what was kept the same in this investigation? The number of iron nail. One iron nail was used throughout the investigation. And what was changed? The conditions were changed. And what was observed here? What was measured? The amount of rust. Okay, the amount was rust formation was observed. Okay, so that from that video you could see that both water and oxygen are needed for iron objects to rust, and salt water increase the rate of rusting. Okay, so let us look at this example. In the experiment below, the nail does not rust when air or water is not present. Remember that 21% of air is oxygen, and calcium chloride, it has the ability to absorb water. So in the first test tube, the iron nail rusted because there is both air and water. In the second test tube, there is water but no air, because when water is boiled, the air goes out, and again a layer of oil prevents the air from coming in. When you look at the the iron nail did not rust. If you look at the third test tube, there's calcium chloride, which has absorbed the water vapor or the moisture. So there is no water, but there is air. So the iron nail did not rust. So from this, we can conclude that both air and water are needed for iron or steel objects to rust. Now let us look at rust prevention. So before we look at rust prevention, can you tell me a few methods of how the formation of rust can be prevented? Okay, good. Now, stainless steel. So one method of rust prevention is to convert iron to stainless steel, because stainless steel is an alloy that contains other metals as well. Together with iron, there's also chromium and nickel. So it doesn't rust, and it has got many uses. It's used to make kitchen sinks, cutlery, example. Now, there are also other methods of rust prevention. In this method, what happens is the iron or steel is covered with another metal. So not with another metal or with some other substance. So this substance will prevent the air and water from coming in contact with the iron. So when there is no air and water, the iron object does not rust. So let us see what other substances or what things are used to cover the surface of the metal. Now first is oiling. Oiling is done for bicycle chains and moving parts of machine. Greasing, this is for nuts and bolts. Painting for car body parts, and plastic coating for garden furniture and wire netting. For example, moving body parts can't be painted. So there will be friction, moving parts of machines. They cannot be, moving parts of machines can't be painted. So if you paint, what will happen? There will be friction and the paint will come off. So this will again expose the iron and steel to be rusted. So moving parts of machines are covered with oil. Okay, now metal plating. In metal plating also, is similar to what we saw earlier. In metal plating, the iron or steel is covered with another metal. Okay, for example, food cans are covered with a layer of tin. Chromium is used to cover bathroom taps. So these are some methods where the iron is covered with another metal. But in the case of paint, for example, once the paint is scratched, then the iron and steel the object below the iron and steel object will begin to rust. Okay, galvanizing. Next, we move on to galvanizing. Galvanizing might be something new for you. Galvanizing is covering iron with zinc. Okay, so this is called galvanized iron. So here what happens is the iron or steel object is coated with a layer of zinc. What they do is they take the iron object and then they dip it in molten zinc. So the molten zinc will stick to the iron or steel, and this is how you get galvanized iron. So let us say that this is a layer of iron, okay, and this is covered with zinc. Now, which is more reactive, iron or zinc? Zinc is more reactive. Zinc is above iron in the reactivity series. So here the zinc is more reactive, so it will easily react with oxygen in the air. Okay, so when it reacts with oxygen in the air, there is not enough oxygen to attack the iron, so the iron will be protected. And also during the oxidation process, iron turns to Fe3 plus ion. It loses electron. Okay, so in this case here, when the zinc undergoes oxidation, it will also lose electrons. So these electrons will move to the iron. So even if the iron loses electron, it will get back these electrons from zinc. So in this way, the iron does not rust. It remains in good condition for a long period of time. So here, even if the zinc corrodes, even if the zinc corrodes, if there is zinc, if for example okay, let me repeat this again. Okay, there's a layer of zinc here, right? So as the zinc reacts with oxygen, it will begin to corrode. So even when it corrodes, if there is zinc left, it will still protect the iron. But let us say all of the zinc has corroded and gone, then of course there is no zinc to protect the iron. Okay, so the iron will begin to rust. Is that clear? So that is why we see roofs of buildings. Initially they will be very shiny, because some roofs, they make use of the galvanized iron, so it is very shiny. So after some time you will see the rust brown color. So that is due to the loss of the zinc layer. So here in this case, the zinc metal is used up instead of the iron. So the zinc metal like sort of sacrifice itself for the iron. So zinc is called the sacrificial metal. Okay, and as I said earlier, zinc is more reactive than iron, so it oxidizes in preference to the iron. In preference means when compared to the iron, it oxidizes faster. Not only that, the electrons flow from zinc to the iron. Next one is sacrificial protection. So the idea of sacrificial protection and galvanizing is similar, but the thing is, in galvanizing, it's iron covered with zinc. But in the case of sacrificial protection, any metal that is above zinc in the reactivity series can be used as a sacrificial metal. Okay, so the common metals that are used will be magnesium and zinc. Let's see how this sacrificial protection method works. Now, first example is in the hull of ship. Okay, the hulls of ship. Now, hull of a ship is the base part of the ship, and this is made from iron and steel. Now this ship is in contact with water and air most of the time, so there's a high chance of it to rust. So in order to prevent the rusting, what they do is blocks of zinc are attached to the hull of the ship, okay, at the bottom part of the ship, as you can see here. So if you look at magnesium or zinc, they are both more reactive than iron. So the magnesium or zinc, for example, let us say this is magnesium, the magnesium will react faster with the oxygen. So there's not enough oxygen to attack the iron or steel here. So in this way, the hull of the ship can be prevented from rusting. Okay, so this method is much more efficient, because once the magnesium reacts with the oxygen, of course it's going to corrode. So once it corrodes, they remove the blocks of magnesium and add extra blocks. Okay, so this way is much it saves time, and it's also can say it's a cost-effective method. Okay. All right. Another one is underground gas and water pipes. Okay. Underground pipes, they carry gas, that is petroleum gas, and they can also carry water. So if these water pipes are these water pipes are made of iron, and again they again in contact with water vapor and oxygen, so they also have a high chance of rusting. So again here, blocks of magnesium or zinc are attached to the pipes. Okay, so here they attach blocks of magnesium or zinc. So the same idea here also, this magnesium blocks will react with the oxygen, and they become oxidized when compared to the iron pipes. Okay, so this part is made of iron. Is that clear? So what happens is, once the magnesium get corroded, okay, once they become smaller, they will be removed and new ones will be replaced. Okay, so don't you think that this is an efficient method of rust prevention? Because if the water pipes are going to be rusting all the time, okay, then what happens? Then you have to stop the water supply, and then you have to dig take out the soil, dig out all these pipes and put them back again. But with this method, all those can be prevented. Okay. All right, so now we move on to the next one, that is the extraction of zinc. So all this while we have been learning about extraction of metals, extraction of iron, then conversion of iron to steel, and then after that rust prevention and so on. So now this is extraction of zinc. Okay, so the extraction of zinc also takes place in a blast furnace. Now, who can tell me what is the difference between this blast furnace and the blast furnace that you see in your in the extraction of iron? Okay, here, yes, good. So here you see a condensing tray. In the blast furnace for the extraction of iron, there's no condensing tray. Okay, so let's see how the reaction happens. Now, the O for the name of the O for zinc is zinc blende. It's called zinc blende. And in this zinc blende, zinc is present in the form of zinc sulfide. Okay, and first the zinc ore is taken and it is roasted in air. Roasted in air means it is heated in air. So when it is heated in air, what happens is the zinc becomes zinc oxide. Okay, the zinc is oxidized to zinc oxide. The sulfur is also oxidized. The sulfur becomes sulfur dioxide. Okay, so both the substances are oxidized. So you get zinc oxide and sulfur dioxide. Now this zinc oxide is taken and then it's like dumped into the furnace. So you see the furnace here. See the furnace. So zinc oxide and carbon, the two substances are put into this furnace. And the furnace is heated by using blast of hot air. Okay, so hot air is blown in. The furnace is heated by blast of hot air. So inside this furnace, the temperature is so hot. So remember, we learned earlier that blast of hot air, the air also will react with the carbon and the temperature will be increased. So here, inside the furnace, what happens is the zinc oxide will react with carbon to form zinc and carbon monoxide. Okay, so this is the simple reaction that take place here. The zinc oxide is reduced by carbon to form zinc and carbon monoxide. Okay, and another thing that you need to note here is that inside the furnace, the temperature is so high that the zinc will become zinc vapor. The zinc changes to zinc vapor. All right, and what is vapor? Vapor is gas. Okay, and this gas comes out of the furnace and then it comes to the condensing tray where it changes to a liquid. Now, what do you call this process where a gas changes to liquid? Correct, it's condensation. So the gas changes to a liquid and then this liquid, the molten zinc is found in this part of the furnace. Okay, and what happens to the carbon monoxide is, you know, the industry, they will have ways to get rid of the carbon monoxide. So all you need to know is that the zinc is formed in the condensing tray. The molten zinc is formed in the condensing tray. So when you look at the extraction of zinc, it is much simpler than the extraction of iron. That not that many steps. Only two. One reaction happens outside the furnace, and the second reaction happens inside the furnace. Okay, so outside the furnace, the zinc sulfide is heated to form zinc oxide and sulfur dioxide. Okay, zinc oxide and sulfur dioxide. The zinc oxide and the carbon are put into the furnace, and due to the heat, the zinc oxide is reduced to form zinc. Okay, so that's about it for zinc extraction. Now, this zinc has got uses. All right, so zinc is used to make an alloy of brass. Now, what metals are present in brass? Copper and zinc. Okay, so what metals are present in what is galvanized iron? Iron covered with zinc. Okay, so this is with this we come to the end of the extraction of zinc. So today's lesson we looked at conditions for rusting and rust prevention and also the extraction of zinc. Okay, any questions on this extraction of zinc? Okay, no question. So now we move on to our activity in textbook. Now look into your textbook at page number 249. Okay, textbook, page 249. We are going to do question number 3 and question number 4. Okay, so let's look at question number 3 first. Please read question number 3. Okay, now let's look at 3A. So when you look at the diagram, you're given 3 test tubes. In test tube A, there is air, there's distilled water, and there is iron nail. Okay, the iron nail is about the iron nail is part of the iron nail is exposed to air. Okay, it's not that the whole nail is inside the water. And test tube B, you have air, there's a drying agent, and test tube C, the iron nail is coated with zinc. Okay, so for each tube A, B, and C, predict whether the nails will rust. In each case, give a reason. Okay, so what do you think? In A, you think the iron nail will rust? Yes. Okay, why does it rust? There is both air and water. Okay. How about test tube B? Does the iron nail rust? No. The reason is there is no water. There is air. There is no water. Okay, there is no water because the water is absorbed by the drying agent. In C, does the iron nail rust? No. Why? Because the iron is the iron is covered with the iron is coated with the nail. So zinc with iron nail is coated with zinc. So zinc here is the sacrificial metal. Okay, so the zinc is protecting the iron metal from rusting. Okay, now let's look at question B. Now for question B, you have to be careful. Okay, the way the question is asked is not very straightforward. Iron from the blast furnace contains impurities such as carbon, phosphorus, silicon, and sulfur. Describe how the level of these impurities is decreased when steel is made from impure iron. So there are some impurities. Okay, read the question carefully, student. There are some impurities. How are the impurities decreased? That is what is asked. Okay, so just because you see the word blast furnace, you should not write about the extraction of iron. Now, this is not asking about the extraction of iron. Actually, what they're asking is the process of steel making, but they don't use the word steel making there. The question is asked in an indirect way. Okay, so you need to be careful, you know, in situations like this. All right, now who can tell me how can, basically this is the steel making process. How can these impurities be removed? Okay, though they put here, how can they be decreased? Actually, how can they be removed? That's the question here. So how can tell me how to answer this question? Okay, good. Oxygen is 3 marks. So you need to write relevant points, 3 to 4 relevant points. Okay. Oxygen is passed into the molten iron. Okay, then what else will you write? The impurities are oxidized. Carbon dioxide, carbon monoxide, and sulfur dioxide are gases and escape from the converter. Silicon oxide and phosphorus oxide react with calcium oxide to form slag, which is removed. Okay, so this is how you write the answer for question number 3B. Okay, so basically all the 4 non-metals are converted to oxides and then they are removed from the molten iron. That is the meaning here. Okay, state a use for stainless steel. State a use for stainless steel. You have learned quite a number of uses. You can write any one of the use. Okay, now moving on, let's look at question number 4. Please read question number 4. Okay, so when you look at question number 4, you are given a diagram, isn't it? The blast furnace is given, and then you have the raw materials given, and the furnace is also labeled. So you are not asked, the question is given in such a way so you can recall your ideas regarding the blast furnace and the extraction of iron. Now, this is a 5-mark question, so you have to be careful and you need to answer accordingly. Describe the reactions involved in this extraction. Include in your description an equation for a redox reaction and one for an acid-base reaction. So here, you need to describe the reactions, but you don't have to write all the equation. Okay, you only need to write one equation for a redox reaction and one for an acid-base reaction. So you kind of give a short summary of the different processes and you write write 2 equations. Okay, do not write all the equations and waste your time, and you will not have enough time then to describe. So read the question and answer accordingly. Okay, so let us first look at the equation. Now, for redox reaction, what is the equation that you will write? The reduction of iron oxide, okay? Okay, so I have not balanced the equation, but make sure when you submit your book, the equation is balanced. Okay, acid base. What equation is that for acid base reaction? So in the blast furnace, there is a reaction where an acidic oxide will react with a basic oxide. Okay, good. So that's calcium oxide and silicon 4 oxide that forms calcium silicate. Okay. All right, so these are the 2 equations. Now you need to describe. So the describing part, I want you to read the notes or the textbook, and you write a short summary like the carbon reacts with oxygen to form carbon dioxide. Carbon dioxide reacts with more oxygen to form carbon monoxide. Carbon monoxide reduces iron oxide to form iron. Okay, and then also you must also include the function of the calcium carbonate. Okay, so when you write all these, you will get a good description. Is that clear, students? Will you be able to write that answer? Yes or no? Yes. Okay, so I want this work to be done in your exercise book, and those who are online, please do in your exercise book and then upload your work using the link provided. Okay, so with this, we come to the end of the lesson. Any questions on today's lesson? If no question, thank you very much.